All right, for lesson 63, we're going to talk about what is called product of square roots rule. And up to this point, we've been talking about radicals or simplifying radicals, something like this. So if we had the square root of 4, we said, what number can you take times itself to get 4? And the answer to that was 2. Or if we had the square root of 16, what number times itself gives us 16? And the answer to that is 4. Now, what do we do in the situation where we have something like this? Say the square root of 10. Now, this is something that's called a radical that's not a perfect square root. So in other words, no number, no whole number, or no integer can I take times itself and get 10. It's not a perfect square root. So how would we simplify this? So that's kind of what we're going to get to in this lesson, is how you would simplify a radical that's not a perfect square root. Now, something that you'll want to write down is what is the product of square roots rule. And what this rule is simply this. If we have the square root of, say, m times n, with m being a number and n being a number, this is the same thing as taking the square root of each of them. So in other words, the square root of mn means exactly the same thing as the square root of m times the square root of n, and vice versa. If I have the square root of m times the square root of n, that's the same thing as the square root of mn. And this is a rule that we're going to use here in these upcoming examples. So let's take a look at the square root of 50. Now, we want to simplify this, and the first thing I notice is it's not a perfect square root. So in other words, 5 times 5 is 25. 7 times 7 is 49. 8 times 8 is 64. Notice that no number times itself is going to give us 50. So we need to simplify this. And right now, something I want to emphasize is this is not considered simplified if you have the radical symbol. So we want to make sure that we can write this. And let me back up. Actually, I can have the radical symbol, but this is not considered simplified if the number inside the radical symbol has a number that's a perfect square root. So this will make a little bit more sense as we go through it. The first thing I want to do is I want to take the square root of 50, and I want to just take 50 and think of two factors of 50 where one of them is a perfect square root. So in other words, I know that 4 is a perfect square root, I know 9 is, I know 16 is, I know 25 is. So for example, I could say, hey, 50 is the same thing as 25 times 2. And I think everybody would agree that 25 times 2 is 50. So really, all I've done is I've taken this and I've written it a different way. I've written it as 25 times 2. But the important thing is I have to have a factor where one of the factors is a perfect square root, and 25 is that. Now back to my product of square roots rule, I can write this then as the square root of 25 times the square root of 2. But what is the square root of 25? 5, and then just simply radical 2. So now this is considered to be my simplified answer. So how do you know if something is simplified? The number inside the square root symbol cannot have a factor that's a perfect square root. So in other words, 50 had a factor of 25, and 25 is a square root. Now if I look at 2, does 2 have a factor where one of the factors is a perfect square root? And the answer is no, because think of the factors of 2, 1 and 2. Well, 2 is prime, I can't break it down anymore. Let's take a look at another example. Let's simplify 200. Now I'm going to show you a couple different ways on this one. First of all, it'd be nice if you can think of two factors of 200 where one of the factors is a perfect square root. And you'd like to pick the biggest one. So, for example, I know that 100 times 2 would be two factors of 200, and certainly 100 is a perfect square root. Now, what this means is the square root of 100 times the square root of 2. But the square root of 100 is 10. And then 2 does not have two factors where one of them is a perfect square root. So this is simplified. Now, I could have done it this way. How about if I would have said, oh, hey, you know, the 25 is a factor of 200, and 25 times 8. 25 times 8 is 200. Now this means the same thing as the square root of 25 times the square root of 8. And then the square root of 25 is 5 times radical 8. Now, does 8 have a factor that's a perfect square root? And the answer to this is yes. So I can break that 8 down a little bit more. And this is where it becomes a little bit more in depth. So let's see, I can think of 8. I still have that 5 out in front there, but think of 8 as 4 times 2, which means 5 times radical 4 times radical 2, which means 5, let's see, square root of 4 is 2 times radical 2. But 5 times 2 is 10, so my answer is 10 radical 2. And notice I get the same answer. Now you'd have the same situation if you thought of 200 if you would use 4. Maybe you use 4 times 50. And let me just go through this real fast. So let's see, this means the same thing as the square root of 4 times the square root of 50. But the square root of 4 is 2 times radical 50. Now, does 50 have a factor that's a perfect square root? And the answer is yes. We just did an example in example 1 of that. So I could think of this as 2 times 25 times 2. Now, I don't have enough room to finish this up, but what would I get here? Let's see, square root of 25 is 5, so I'd have my 5 times 2, and then the radical 2. And notice you get the same answer, no matter how you do that, just so you have start off with a factor that's a perfect square root. All right, last example is 108, square root of 108. So let's take a look at that. I want two factors of 108 where one's a perfect square root. So I want to be thinking, you use calculators on this. You can, let's see, 4 is a perfect square root, 9 is a perfect square root, 16, 25. Let me try 4. So I'm going to think of, let's see, what can I divide 108, or 108 divided by 4 would give me what? Let's see, I get an 8, bring down the 8, 7. So 4 times 7. So 4 times 7 is two factors of 108 where one of them is a perfect square root, which means the square root of 4 times the square root of 27, which means 2 radical 27. But am I done? Does 27 have a factor that's a perfect square root? The answer is yes, because I could write 27 as 9 times 3, which means 2 times radical 9 times radical 3. Let's see, square root of 9 is 3, so I have 2 times 3 times radical 3, but 2 times 3 is 6, radical 3, and I'm done. So this is the topic was called Product of Square Roots Rule, and what we've really talked about then is just simply simplifying radicals.